This video is on the basics of exponents. So this is a review from starting in pre-algebra and algebra, and we do some in geometry. But let's just make sure everybody understands the idea and the vocabulary. When we have an exponent, we have a base, and that's the number, that's the full-size number, or variable. Then we have an exponent, and that's the power that we're raising that number or variable to. This is just shorthand. What it really means is I have 4 times 4 times 4. 3 of them, and that's what the 3 means. So if I had x to the 4th power, that's just shorthand for x times x times x times x. And if you keep that in mind, then all of these rules of exponents are really just shortcuts to doing exactly what that says. I'm going to pull that down. Okay. First thing we're going to talk about is multiplying these exponents. So when they have the same base, that's when these rules apply. It's important to note that. If I have x's and they both have the same base here and they're being raised to a power, then when I multiply those two bases together, I add the exponents together. So x squared times x to the 3rd equals x to the 5th. Why would that be so? Well, remember, this is shorthand for x times x. So here's 2 of them. This is shorthand for x times x times x. That's 3 of them. 1, 2, 3, 4, 5 of them. That's why it's x to the 5th. Okay? Now, let's look at a more complicated problem. 3xy squared times 4x squared. Well, I have numbers, so first thing I do is pull the numbers down and multiply them together. 3 times 4 is 12. Now I'm going to look at the x's. I have 2 x's here and 1 x here, so I have x to the 3rd power. And here I have a y squared and nothing else, so it stayed y squared. That's how I'm going to multiply different powers together. Notice I didn't combine the x and the y and make that to the 5th. They have different bases. I'm only going to combine the exponents when they have the same base. Now let's talk about dividing. When we divide, we're actually going to subtract the exponents. So if I had x to the 4th y over x squared, this is really what I have. Remember, this is shorthand. I have 1, 2, 3, 4 x's, right there, and 1 y. And on the bottom I have x and x. And just like simplifying fractions with regular numbers, whole numbers, I'm going to cancel whatever appears both on the top and the bottom. Because x over x equals 1, and x over x equals 1. Now I'm left with 2 x's up top, x squared, and a y, and nothing on the bottom, just a plain 1. So subtraction comes from me saying x to the 4th minus 2 is 2, x squared y. And y didn't have anything down here, so it stayed just the way it was. It had nothing to subtract. Let's look at an example here. D squared e over 2d. First thing I look at is the 2. There's no number there, so the 2 stayed right where it was. This is 2 d's on top and 1 on the bottom. 2 minus 1, I'm left with 1. And there was only 1 e on top, so it stayed right where it was. Okay? And the last concept we're going to talk about is raising a power to a power. When I take a power and raise it to a power, I multiply the exponents. That looks like this. X squared, in parentheses, raised to the 3rd power. So I do 2 times 3, 6. Because what this really is shorthand for x squared times x squared times x squared, right? There's 3 of these. And 2, 4, 6, there are 6 x's there. That's where the shorthand works. So let's take a look here. Whenever you have something in the parentheses and you raise it to a power, you have to distribute that power to everything in the parentheses. So the first thing I do is write that as 3 squared and x squared squared. So making sure that I use that squared. Because of the parentheses, that squared goes to everything inside. So 3 squared is 9, and x squared to the squared is 2 times 2, x to the 4th. So this is the simplified version of that. Okay, let's do a few examples together. Okay, take a look at this first problem. We have a multiplication problem. I see it right here. So first I'm going to multiply the numbers together. Negative 9 times 3 is negative 27. Then I look at the y's, because I have a y here. I have 1y, 2y. And last I see I have an x squared. Done. Let's look at the second problem. I have 20 and negative 20 and negative 2, so I have positive 40. I have 1 h here and 3 h's here. So I have 4 h's altogether. Now, a division problem. Now I'm going to take a look at each thing that's on the top. I have a number on the top 4 and I don't have any numbers on the bottom. So my 4 stays right where it is. In x's, I have 2 x's on top and 1 x on the bottom. 2 minus 1, they cancel, and I'm left with 1 x. And now I have 3 y's on top and 1 y on the bottom. 3 minus 1 is going to leave me with 2 y's. That's my final answer. Okay? Look at this one. 2a to the 4th over 4ka squared. First thing I notice is I have a 2 and a 4. So I know that I can divide a 2 out of that and get a 1 on top and a 2 on the bottom. I just divided both of these two numbers by 2 to simplify my fraction. Then I have 4 a's on top and 2 on the bottom. 4 minus 2 is 2 a's left on top. And I have a k on the bottom and no k's on top. So k just stays on the bottom. That's my final answer. I hope these are all coming back to you. Your great memory. Okay, last thing I want you to do is write down this complicated problem, please, in your notes. Bring this to class and make sure that you didn't have any trouble solving it. We'll go over this when you get to class.